In this video, we are going to study our next chapter in 4th unit, that is ultrasonics. So, what is meant by ultrasonics? Ultrasonics, that means beyond the audible range. Okay, so audible waves are that confined to the frequency range from 20 Hz to 20 kilohertz. So, such waves are known as sonics. Okay. Example, the waves produced by vibrating bodies such as stretched strings, those are known as. Next, infrasonics. Infrasonics means infrasonic waves are that range of sound wave frequency within which the human ear is not capable of receiving sound energy. Okay, we are not able to hear those infrasonic sounds. Usually, infrasonic waves have their frequency less than the lower limit of the audible range. That means below 20 Hz, we need it as a infrasonics. We are called it as infrasonics. Example, these waves are produced by large sources such as earthquakes, like that. Okay, and next, infrasonics. What is the infrasonics? We will see here. Ultrasonics. The sound waves in which the frequencies are above the limits of human audibility, that is frequencies greater than 20 Hz, those are known as ultrasonics. Okay, so these are nothing but supersonics also. Between 20 Hz to 20 kilohertz only the human audible range. So below the 20 Hz we know that as infrasonics, and after 20 kilohertz, above 20 kilohertz, the sound is known as ultrasonics or supersonics or hypersonics. Okay, so the sound waves in which the frequencies are above the limits of human audibility, that is frequencies greater than 20 kilohertz, that are referred as ultrasonics. Because of high frequency, we can't hear these waves. Bats and dogs are able to hear such waves. So the wavelength of ultrasonic waves are very small as compared to the audible sound. So most of the applications of ultrasonic waves have been possible due to their smaller wavelengths. Okay, it has due to the smaller wavelengths, it has a wide applications. These waves, also known as supersonic waves, sound waves of frequency higher than 10 power 8 Hz, that are known as hypersonic waves. Okay, let us see what are the properties of ultrasonic waves. Okay, so the ultrasonic waves are highly energetic, high frequency in audible sound waves. Okay, these are highly energetic waves and high frequency in audible sounds. So they show negligible diffraction due to their smaller wavelength. So it shows the diffraction very negligible. Hence they can be transmitted over long distances without any loss of energy. So intense ultrasonic radiation has a disruptive effect in liquids by causing bubbles to be formed. Okay. So what happens here? Intense ultrasonic radiation has a disruptive effect. That means in liquids by causing the bubbles to be formed. Ultrasonic wave requires a material medium for its propagation. Their velocity of propagation is directly proportional to its frequency. So velocity of ultrasonic waves, that is the propagation, it is directly proportional to its propagation. Their velocity of propagation during the propagation of ultrasonic waves, they are reflected, scattered and diffracted. So the diffraction very negligible as compared to its wavelength, as we earlier said. Ultrasonic waves set up standing waves in liquid baths and in turn produces an acoustical grating whenever it passes through a liquid. So ultrasonic waves set up standing wave in liquid baths and in turn produce a acoustical grating. The acoustical grating is also one of the topics in this chapter. Okay, let us see what are the production methods of ultrasonics. So ultrasonics waves are usually produced by the application of magnetostriction method and piezoelectric method. In general, waves will produce the ultrasonic waves.